Hello? Just give me a sec. Okay. So it's time to figure out what we're actually doing. Let me change the stream, like name. So what are we doing? Let's see. Okay. So it isn't this. It isn't this. It isn't this. It isn't this. It's something else. Right. JS and RXJS. RandomX.js. What? The fuck is this? There's news? What the fuck is this AI generated fucking bullshit? What? Okay, whatever. This is like, what the actual fuck? Oh, okay. I put this up. What else? Oh, it's in China. Okay. All right. So it's time to get done. Okay. So if I'm gonna change this to modernizing and okay. Library. I'm gonna like fill it out more. RXJS as a library. It basically implements hashes in the web. I have a video on it. I have a video on it. Like that. Nope. Go to the YouTube. this thing. I got a video on this. Maybe I can copy the link. Just copy this. Yeah. Copy this, paste it here. Maybe it embeds nice. Maybe. It's the build system, maybe. What's Reacts? No. So yeah, Equix. Equix Tevidor. This thing. Equix. Equix? But there was Equix. What? It's not Equix. Equia. Yeah, Equia. Well. Okay, so what is this going to be named? This is going to be named this. RXJS. Okay. Done. Okay, what else? So what actually needs to get done? So let me open, maybe I have a folder. Because this is a very old project, keep in mind. Very old project. Okay. Oh, there's like a couple stuff. Does not have VLC dispatches. Oh, pre-compute scratch pad address. There's like a ton of stuff. So okay, I'm gonna write them all out. So all these need to be done, really, I think. RandomX batching API. Mining. Figure out why FMA is broken. That's probably a good one. Look into. I know I looked into this. Why is that like a thing? Okay, computing scratch pad addresses. Register allocation, probably. Register allocation. Library. Cryptography code. There's some other stuff, right? Maybe. Deprecate. instead. Okay, I'm just copying this from my notes. There's branch hinting. I don't think that would be very useful though. No, it's not. There's batching API. Oh, register allocation. Yeah. Since we get, let me see. Since we get the baseline JIT. Since we get cryptography code. What else am I missing? RandomX calculate commitment. Maybe get into. I know I miss this function. Yeah, there's a lot of stuff that I'm just missing. What else needs to be fixed? Make files. Okay, yeah. Of shared memory. Instead of binary patching, use slow and can't be the binary patching. It's because you're slow and code can't be streamed. Deprecate the and just make two different modules. Just make two different modules. That's another thing. Okay. All right. I'm gonna push that up. I'm gonna push that up. Yeah. Oh, this is called stream lean. Stream. Yeah. Nice. Great. Okay. This is the perfect time to start. All right. So, let's see. So this is what I wrote on the Discord. Give me a second. Config. Pick on. Yeah. Let me just get rid of this. Thanks. Okay. All right. So let's start. So, it's been a bit So this is the last stream. What did we do last stream? I actually don't remember. What did we do last stream? Okay, we implemented this like proof automation stuff and like salvaging the proof. This was like a general issue. So encoding the hypothesis. So the definitions for the LLVM instructions are fine, totally fine. It's just the problem is just that like encoding assumptions. For example, if you were to and I'm in NeoVim at the moment. I'm giving this a go. But what's a good example? Identities. Yeah. So what's a good example? No, these are the wrong example. Basic binary. So these assumptions, for example, here, right? H A S sub overflow B, right? This assumption is not something that should exist. So really, what should be written is oh my god, how the fuck do I use this thing? Why is it so slow? Okay. Oh, because it leans like fucking up. Why is it taking so long? Okay. The problem is that this thing, this doesn't like what should really only exist is these things. Oh, nice. These should only exist. Because these are like things that I can export. For example, I can't really export this. This is a bit vector. This is like a bit vector thing. That's like a lean dependent thing. It's part of Lean's API. So what would be better is if I just had like defined hypotheses. So I've had like s sub like a sub overflow. That's not how you spell that. Sub overflow AB or like not sub overflow AB like as actual hypotheses would be way better. So for example, like this is like kind of harmless, but when it comes down to the shift operations, right? For example, the shift operations, I think that was like shown off. Oh come on, why? Yeah, I don't know. With lean, it's like slow. I think it was shown off here, right? For example, like yeah, there was problems here where it's like I'm encoding this, right? The bit vec n is greater than 1. Then I have to encode that the b is actually less than n. That's like a really weird, like obtuse thing to encode. So I would rather write like lt width, for example. I would just write that, for example. So that would be way better, and that's basically the plan. But the thing is like there's a ton of other stuff as well that I need to think about with this, so they haven't spoke about. Things like the distinction between immediate undefined behavior and normal undefined behavior. So for example, there's two different types of undefined behavior. There's poison, right? And that's the undefined behavior we model. But then there's other kinds of undefined behavior like immediate UB. Immediate UB is for things like exceptions in the CPU. So if you divide by 0, right? If you have like this if you divide by 0, right? This shouldn't return poison. This should throw like a literal control flow exception. So that's my problem. Just rewriting Golang. I don't know how Golang would help me, at least for this. Well, what Golang does is that it also throws an exception as well. All right. Okay. So, Golang has everyone everything. I like writing it. It's actually like it's like my favorite like programming language, like to just write stuff in, like web stuff. It's nice. It's nice. Yeah. Okay. So this is gone. So we're not doing this today. We're doing this. So lean's gone. Okay. So, I hope that everyone is like acquainted with like what RandomX.js is. I'm gonna I put the video in the chat as well. Oh, not the video.
Hey.
Yeah, I put the
All
video
right.
in the chat, but I
Hello
didn't. I'm
everyone.
putting the repo as well.
My name's Liam,
Um,
and I have a talk
so
called
if you're
Zero
interested, you can watch the video as
RandomX.js,
well.
bringing
But
web mining back.
RandomX.js is basically an implementation of the RandomX hash function in JavaScript, right? Illegal web crypto mining. Well, the only reason why I did this is because it's a nice engineering problem. Actually, I can just like show parts of my I can show. Oh, here it is. Even I can show parts of my talk, right? So if you can't watch the video, where is it? Yeah. So okay. I guess I can just like show the slides. Um, yeah. Okay. So this is the whole problem with RandomX. So this is on RandomX's README, right? RandomX says, okay, so web mining isn't feasible due to the large memory requirements, so fair, and the lack of directed routing support for floating point operations in both JavaScript and WebAssembly. So this thing, right? This thing is like the killer. So this is the reason why RandomX, I guess for like 5 years, right? 5 years straight, like just like hasn't been able to be run, hasn't been able to be run on the web, right? Because you don't have access to these other different kinds of rounding modes. I think I can like just scroll over to them. Um, but yeah, so like, why did I do this? It's a fun engineering problem. Like when I was working on this, like RandomX, this is basically this was like during high school. I was like skipping classes. I was like, well, I wasn't skipping classes. I was like all the study periods that was like assigned to me. I wasn't like studying at all. I was just like working on this. I was so lucky I like didn't like bomb out of high school. But yeah, this is what I did during high school. So yeah, so 5 years later, this is possible. So for 5 years, RandomX hasn't been a thing on the web because the web is nothing. Now the web has something, so we can actually do this. But what's left is the emulation of these floating point rounding modes. So like these floating point rounding modes, like they're weird. I can show them off. Show them off. So okay. So these are different kinds. So let's say x is a real number. So that's the result of like a computation, right? You like x plus y. This is a real number. Um, so after you perform an operation in floating point, in like the floating point world, right? You do x plus y, right? After you perform an operation, it has to how it's defined in IEEE 754. It computes the operation with infinite precision. So it's like you're adding x and y as real numbers, right? And then at the end, you round them down back to floating point numbers. So this x here is just the result of some floating point like math. And then depending on your FPU state in the CPU, it'll pick one of these four to round your number to. So this x is a real number. If your like CPU is set to round up, it'll just like snap. It'll like snap it up. If it's set to round nearest, it'll round to the nearest tick, right? Um, so these things 1, 2, 3, 4, right? RN stands for round to nearest. Round to nearest is the only thing that you have like that's accessible. These other three rounding modes are more like low level kind of things. So I think I can scroll up, right? I think I show that these things like just don't exist, right? For example, oh here it is, right? So in C, JavaScript, and Rust, for example, like all of these programming languages, Python, and so on, right? These only implement round to nearest. In fact, you don't have a choice. You can only do round to nearest. The only things that let you do this is like in C and C++ is that you can actually have access to the fnth state, right? Using fnth access. So if you set this pragma, it's no longer undefined behavior to to change the rounding mode. So this actually like follows the semantics. So you need to basically emulate these. Emulating these is hard, right? So there's two ways you can emulate the different kinds of rounding modes. So you could basically go here. What you could do is, so here's the way like I implement them. So yeah, okay. So you could implement it like this, right? Using soft float. So you basically re-implement the entirety of floating point using integer math, and it's just a bunch of if statements and binary crap, and it's slow. It's incredibly slow. It's very slow. In fact, like I have a benchmark here. So red, right? This red is hardware, right? So this is like baseline. It's the fastest, obviously. It's hardware. Blue is my implementation. I use something called semi-float. It's just the name that I made for it. It's only 1.8 times slower, so 2 times slower. It's not that bad. This orange here, this is soft float. So soft float is like implementing it using integer math, right? This is what people thought they would have to do if they were to implement RandomX, right? So it's like, okay, you need to implement RandomX on the web. The web doesn't have these rounding modes. Okay, so you just need soft float. Soft float's the only way. Well, this exists because it's not the only way. It's not the only way. So this, my way, the blue way, it's better. It's way better. It's like 10 times better. So all this overhead is killed. So how do you actually implement soft float, right? So soft float is special. So the way it's done is basically, right, to measure error. So let's take x as a real number, then x is equal to the rounded part plus some epsilon, right? We can solve for epsilon. Epsilon's the error in the computation, right? If e is 0, if epsilon's 0, the operation was exact, right? Because x equals the rounded part. If epsilon's greater than 0, the rounded part's greater than x. It's just algebra. If epsilon's greater than 0, we round it down, so the rounded part's less than x. So the point is, right, we have control of the rounding mode ticks. If you scroll up, right, here, let's say x is a real number, you can either go up or down. You cannot go any further than that. So if you, let's say like we wanted to emulate round down, right? If we round it down, we can detect it. We round it down. Oh wait, that's okay. We're supposed to do that. But if we round it up, we can detect that we rounded up. Oh shit, we rounded up. Now you can round down. So detecting whether you went up or went down is basically the way to implement these other rounding modes in terms of Rn. So it's very simple, right? You implement like x plus y using Rn. Okay, and then you either go up or down with the rounding mode. You check if you went up or down. If you're implementing round down and you went up, you want to go down, right? And the other way around as well. So that's how it works. So this kind of thing, right? Rn star, right? This is like some abstract, like fake function. It takes in like x, a real number. It returns the rounded part and the epsilon error. These are both floating point numbers. So in general, Rn star doesn't exist. It's not like a real thing. But it doesn't exist in general. But it does exist for certain operations, right? So let's say we had it, right? So if we had it, put this here, right? Let's say we had it. So if we wanted to implement fadd1, fadd1 stands for when FPRC is 1. So this is in RandomX terms. This is round down. You always want to round down. So to implement this, let's say we had Rn star for x plus y. Well, we get the sum plus the error in that sum. If you do sum plus epsilon, you get to the actual real number of x plus y. So all right. If e is less than 0, if epsilon is less than 0, we round it up. Okay, well, we want to round down, so we minus ULP. Or, if epsilon equals 0, or epsilon's greater than 0, we already rounded down, or the operation was exact. So there's no rounding needed to be done. So this is it, right? The entire thing is just this, right? We detect if we rounded up. If we wanted to round down, we just snap it back down. Right? This is based on the fact that when you do an operation, there's only two places to go. You round up or you round down. There's only two places to go. So that's it. That's how I implement This is called semi-float. This is much quicker because you can do this in the CPU. This is a branchless. You can do this branchless because it's a unpredictable branch. This is branchless. You can make this branchless. All of this is branchless. This is in the CPU, right? Um, like there's like code for this. It's just like Rn. It's just like x plus y. You can just do this. So you can do x plus y because that's Rn is what you get. Rn supported. But how do you get the epsilon, right? So Rn instead doesn't. I said Rn instead doesn't exist in general. But it does exist for some summation. So for example, this is called toSum. This is an algorithm by Decker, I think. So if you do basically what it calculates, right? You just put in x and y. It does all this weird stuff using Rn. Basically, this is just like math that you can write, like in JavaScript, Rust, C. This is just like addition, subtraction, and so on. And then you get epsilon error, right? So given toSum, you can just sub it in. It's the same. But I'm not lying here, right? You can literally implement this in C. So to implement this in C, this fadd1, super simple. So sum residue is basically toSum here. It doesn't return the sum, it just returns the epsilon, right? So I compute C, which is just this S here, right? It's the sum. The residue is the epsilon. So I just check, right? Is the epsilon less than 0? You want to snap down. You use something called next after. Next after C basically gets the next representable float in the direction of the second operand. So it's just like gone one down, right? It's just gone one down. Else, we rounded down, or it was exact already. Return C. So this is a real function you can write down. In fact, like, I can just like show it. Where is it? Semi-float. I can show it. I can just show it off. Here it is, right? It's just like you calculate some residue. That's the res. These are oh god, this is so hard to read. Scheme. Hopefully there's like a better color scheme, right? How do they like telescope color scheme? Oh, that's nice. That's nicer. Okay. So, right, fadd1, you sum them. So this is working over vectors, right? This is SIMD. So sum residue, that's it. And then this thing, right? This thing, this if statement, this is next after one finite. So this is basically a branchless implementation of the next after and the return. So what it basically does is just like branchless stuff. It's just branchless stuff. So that's it. Really, that's it. So all of this work to do with the floating point stuff is the reason why RandomX.js like can exist. So the reason why it can exist, right? RandomX forces non-trivial floating point rounding on you. The reason being is that it needs to be ASIC resistant. There's like the first section in this talk I go over ASIC resistance. But all of these other programming languages like WebAssembly, JavaScript, you only have Rn, right? Fair enough. The other rounding modes are low level kind of things. For you need to have access to the FPU state. So you can't really do that, right? Because you're in a sandbox. So you need to emulate it. So the slow way is using software, right? That's the slow way. You don't want to do that. That's like 10 times slower. It's actually like terrible. So you can use these things called EFTs, right? That's your Rn star, right? toSum is one of them. Toprod is one of them as well for multiplication. So you can implement it using this, right? And then it's completely branchless code, right? So the bane of slow software implementations is like unpredictable branches, right? Floating point math, if you're branching on the bitwise representation of a floating point value, that's literally unpredictable, completely unpredictable. So you have to do it that way. You have to do it branchless, right? But you can't really do soft float branchless. You can't. You can't do it branchless. That's like impossible. It's like really annoying. But you can implement it using this thing called semiflow, which reuses the existing circuits you have access to. You already have access to Rn, so you don't want to throw that away for an implementation that uses all integer instructions. Because floating point math, you already have. So that's it. This allows RandomX.js to be fast. So here's the talk. If you want to look at it, it's on YouTube. I basically, it's got everything here. Everything. This is like a very comprehensive talk about RandomX.js. It's not very comprehensive about RandomX. It's like a bit comprehensive. So, for example, like it shows off right? It shows off the algorithm, right? It shows off the algorithm. So it's a huge algorithm. It's huge. It's got a billion, like, tons of moving parts. The reason being is like ASIC resistance is a very, very hard thing, right? This is like state of the art, like ASIC resistance. This is like near perfect, but it has to be so over engineered because of that, right? These ASIC companies are so fucking slimy. They're so slimy that any little like they'll literally spend like $1 billion to exploit like anything in your hash function, just so they can fab it. But this is basically like the solution against it, really. So it's like it's split into two sections. So the first section is called the dataset. So the dataset is it basically enforces memory hardness. So the dataset's 2 GB in size. It's just a memory pool, an immutable memory pool that you have to create in the beginning. And the virtual machine, so the second section, it samples from that. So you can think of these as like black boxes, for example. So this is the virtual machine. So the virtual machine is literally a virtual machine. It's just a virtual machine. It's just a virtual machine. Like there's not much to it. It's just that a lot of the instructions and the way it's set up, the scratch pad and everything, it's to be as close to a CPU as possible and to maximize the entropy, right? So like the entropy creation. So the whole point of this RandomX VM is it takes in the hash values, it runs multiple programs on it, chains multiple programs to basically fill the scratch pad and register files with entropy, then hashes both of them and returns the result, right? So like a hash, like in like running the RandomX hash, it's dependent on like code and data. So you have to run code to do it, and it kills basically like running it on chips. So yeah. So this goes pretty in depth. So like if you're interested in like the implementation and the floating point stuff, it's all here. So you can just watch that on YouTube. So yeah, so the overview. This is a complete rewrite of RandomX, right? So the core RandomX was in C++. I rewrote the entire thing in C. It was just better. Like I don't want to deal with C++. The TypeScript section, it's not that long. It's just a little bit of code. It's got the same tests, so it passes everything. No interpreter. It's made to be as fast as possible, straight up, just straight up fast as possible. And it's only 5 times slower, so that's not that bad. I think that's a win. I think that's good. So, what are we doing? Let's see. So, if you look at the code base, right? This code base is 2 years old, basically. It's basically 2 years old. Yeah, it's just old. Like, a ton of stuff needs to be fixed. Well, there's not a lot of stuff. The thing is that actually the you can just like run RXJS. Let's run the tests, right? Oh shit. I don't know, bun test or something. Why is it not running? Okay. I forgot how to build this. S. Um. How do you build this? Scripts? Yeah, scripts build. Okay, it's like huge. Build. Okay, so the tests are running. So hopefully bun is a bit better. Because bun, like, actually sucks. Semi-float, why? Huh. Segfault? Okay, never mind. That's probably fine. So this works. So if you actually look at the what's it called, tests, right? Examples. Here's an example. So how it works. It's just like RandomX init cache. Take the cache, you make a virtual machine. RandomX calculate hex hash. So we can do this. So it's just node. Yeah, node. So it takes a second to compute the hash. So yeah, this is 11 hashes a second because I'm clocking my computer down like by 2. So yeah, it should be like the hash rate should be like 20 hashes a second. This is like for a single thread. Like so this is like pitiful. This is like nothing. But the hope is that like for a single this is for like a single thread. So it's like 20 hashes a second. Um what you can do is you can make it threaded and you can put it on like 20 different PCs. So then that's like not that bad. It's not that bad. So yeah, that's basically the idea. So it does run. It's on npm. It just runs just fine. But what needs to be done is I think I've written it right. I've written it. So RandomX batching API, that's important. So if you actually look, RandomX. All right, I'm switching to VS Code for this because I was just like, I don't want nonsense. I can't even like navigate. I wouldn't even know how to navigate this code base. RandomX.h, right? If you go to RandomX.h, there is batching. Batch. What? Where's like batch? Oh, here's batch. Here's batching. Um, yeah, it would be nice to implement like this batching API. So you basically mining is just like hashes. Like you just you literally compute hashes in a loop. Um, yeah. So the pointer to memory to be hash for the next hash. So like if you do it like this, right, it'll use the previous computation for the next one. This is better. This is like better. So it would be nice to implement batching. I need to figure out why FMA detection is broken. So FMA is fuse multiply add. If you look at the presentation, fuse multiply add. Where's like as an opcodes? Here you go. This is my favorite website. Relax SIMD. MAD. So relaxed add. So this is FMA. So this is like it does A times B plus C, but it doesn't do it like this, right? A times B plus C. It doesn't calculate. So for example, like it will do this operation, then round, then do this operation, then round. What it does instead is just like A times B plus C, right? It'll do this operation, then round at the very end, right? It rounds at the very end. So that's just like you can use that. You can use that with some like bit trickery to basically implement uh the semi-float for multiplication like much faster, like only 30% slower. The thing is that you have to do feature detection. So if you use so for example, like CSR says here, the entire expression is evaluated with high precision and then rounded only once if supported by hardware. I have to check if that hardware like actually supports that thing. Otherwise, like this will be compiled wrong, it'll generate the wrong hash and everything will just like crash and burn. So I have to do feature detection, and I do feature detection. But the thing is like I think the feature detection is like broken because the feature detection returns true, right? It returns actually I can like where is it? Like shit, how do I search? No. No. Yes. Yeah. Detect. This is like my detection, right? Detection is basically like do this operation, do this operation. This should like equal exactly this, right? If mad is right. Um, this always returns true for some reason. So it's always saying that it like detects the thing, which is crazy to me because whenever I actually run the code, it doesn't actually detect the thing. Um, it doesn't actually generate that code. I think I can like show it, right? Where's the like index? Right. Okay. VM.ts. Oh yeah, JIT feature. Okay, JIT detects. Okay. Um, where is it? Like detect.ts. Okay, so how I detect is basically what I do is I get that WebAssembly thing, I run it, and then if it returns true, the FMA is working. So this returns true basically for Firefox and Chrome. But when I actually generate the code, I think I can show the code. Uh, what is it? JIT VM FMA. So this actually like swaps out the FMA stuff. I think yeah. So it basically checks like if JIT feature FMA, if JIT feature like JIT FMA is true, it puts these stubs in. So the semi-float that I showed you, this compiles to like a WebAssembly like blob, right? And these just get inserted into the binary. So I can pick, right? I can pick when I JIT the code. If you look at these, right, it's just like these. So where's the FMA? So these get used, right? This is relaxed mad. This should work. When the code gets run, these execute with 2 roundings, not 1 rounding. So it breaks everything. So it's like, what? I have no idea. I have no idea how to fix that. So I guess I'm gonna look into that. Oh, 0. I'm gonna look into that as well. Improving JIT code patterns, register allocation needs to be improved because we only get baseline JIT. We need to do optimisations ourselves. Cryptography code. This is like number 1. I do binary patching. When I go run the code on the web, I do binary patching to like switch it out. So like if you want to use shared memory, if you want to like mine using threads, you want to use shared memory. So I would like patch the binary to enable shared memory. That's bad. Like because you can't stream you can't stream the WebAssembly code straight into a module. That's bad. This needs to be changed. Like if I have to I would be able to the solution to that is like make 2 libraries. The first library is like RandomX.js, and the second library is like RandomX.js threaded or like shmem or something. Yeah. And then maybe deprecate this. This is like optimisations. That's also optimisations. Okay, so let's do binary patching. So, yeah. I think for the moment, so I know I'm using NeoVim, but this is like, I need to like fix a ton of stuff. Like, what are these like red, like just stuff, and then like, it just feels weird. I'm so used to like VS Code, so weird. Persizzle, what's up? Hi, it's good to see you. Good to see another chatter. Yeah, so like NeoVim is like just like pissing me off at the moment. Like I switched to it like yesterday. Like I used like Obsidian Vim. Like I'm used to Vim. I'm used to Vim. I'm used to Helix. Like I would use Helix. Um, I would use Helix, but they don't have lean support. Lean support, like the only two editors that are supported are VS Code and Vim, right? NeoVim. You seriously, like, you just can't get lean support. So like I have to use NeoVim if I want to switch. But yeah. Oh well. Are you a hobbyist or do you do code filming? No, I'm a jobless bum. So there's a hobbyist. It'd be nice to have a job, you know. But nah, I don't have a job. Okay, so I'm just gonna switch to VS Code because this is just annoying me. So we can actually get some work done. All right. So log. Okay. Let's do this. So in the make file, this is like terrible. So the way I implement shared memory is with binary patching. I can show this off, right? Adjust imported shared memory. So it'll literally find the import and then like, for example, if you look at the like WebAssembly spec, right, there'll just be like a little tiny, like in the memory sections, there'll be like a tiny little thing which just says mem type, right, and you can just change the limits. So here, right, OX03, that's shared. Um, I need to switch it to be shared, right? Oh, are you looking to break in the field? Something like maybe. Yeah, I'm Australian. Yeah, I'm in Sydney right now. Like, this is my talk. I did a presentation about this entire thing, getting RandomX working. Right, this is at Units W. Just straight up, like I just go here. So yeah, I'm looking to break into the field, but the thing is like I'm kind of like dooming because like I don't want to do leak code and shit. Like the thing is like I've been doing like WebAssembly and systems programming for like years. Like I literally like know WebAssembly, like the back of my hand. I've been doing compiler work. Like I was working like the V programming language. Like I've made my own compilers. Like I do like I've like self-hosted like stuff as well. Like compilers as well. The thing is like there are no jobs like that for like intro people. I feel like my only option is like research. Like unfortunately, no, I haven't been applying. I haven't been applying, but like the thought popped into my head very recently, like the realization that like I'm gonna be 20 next year. I'm gonna be 20 next year. I'm gonna be jobless. Like that's not a good look. That's not a good look, unfortunately. So that's like that's I'm gonna be applying. I'm gonna be applying, but I'm not too optimistic. You know, if that makes sense. I'm not too optimistic. But yeah. Oh well. Um, Doom 37 is breaking the web foot. Oh yeah. I mean, fair enough. Yeah. So this needs to be. Yeah. So I can't do binary patching. Like it's just not a thing. It's just not a thing I can do. So this, God, this makefile fucking sucks. Look at this makefile. What is this? Like, what is this shit? So all of these things, like, there's a lot to fix. There's a lot. Yeah. a lot to fix. So RX harness is one thing. It's a data set. It's a data set. So the web miner. So I'm gonna comment out the web miner stuff. Self-taught dead in the first person interview. Oh, nice. All right. Yeah, I hope it goes well for you as well. Yeah, I hope it goes well. So this data set needs to go. Okay, so I'm gonna like comment out like a bunch of shit. So web miner, that's RX web miner. It's the data set. Why is the data set and VM separate? Oh, yeah, okay, that makes sense. No growable patch. Yeah, okay. All right. So I guess the problem is build TS. So web wasm stop. Okay. Wasm binary. Yeah, this is like really like scuffed. This is like really fucked up. I'm in the States though, so I have no idea what the market is like in Sydney. Yeah. Um I don't think there's much here. I don't think there's much here. Um yeah, bear with me for a moment because this has been it's been 2 years since I looked at this code base. It's been a month since I've wrote a talk on this. So it's like it's kind of fresh in my mind, but it's like kind of not. I'm trying to remember. So the way I did this, okay, single. So this is VMTS. So how it works. So the data set is its own thing. This is like a WebAssembly binary. That's probably fine. Yeah, I need to patch this in place. So that's not what I want. So I'm gonna hide some of these, right? So the VM is its own thing. The data set's its own. Okay, so yeah, so I need to duplicate this, right? I need to duplicate this. So I need to have the normal thing, and I have the shamem version. Should I write shamem or shared? What is even is like shamem? Shamem is like that's like the term for it, right? Or should I just write shared? Shamem, shum, shared. I think shared is better. Okay. Okay, so this is package RandomX.js. And so there's no global patch. It's in scripts. Stubgen. Oh, that's nice. No global patch. Okay, so just imported share memory. I need to make like a thing for that. No growable patch. It's been a while since I wrote TypeScript. Shared patch. So I'm going to patch the binary. What's the needle? I mean, what do I put in? It's just like locate import, right? Yeah. Dun, dun, dun. Locate section, binary. So like, what, how do I use this function? Oh, okay. I should have used it like this. So, it's just okay. So, how do I import this? Yeah, okay. Line real. True. Okay. This doesn't return anything, does it? No. Great. Patch successfully to RX3. Bad. Okay. Hopefully I remember how to do all this WebAssembly stuff. So web wasm dis. Dataset. Okay, so that's not what I want. Is there like wasm obj dump headers? Yeah, okay, I remember. No, it's not headers. It's details. Details. Okay. So import. So this uses, yeah, initial that max, that's env memory. So I need to patch it. So it's just like this, right? With I want to patch. So okay, I want to patch this, right? I'm gonna see if it works. With this. Okay, it's successfully patched, so let's just check it. Didn't say anything. Maybe because it's like not saying it right. Maybe there's like a, is it like WASM something? WASM stats? No. Surely there's like a thing, right? Okay, I'll just like WASM disk because it probably like writes it nice. Nope, a.wat. Okay. Import env memory. Why is it not doing that? Why is it not saying shared? Hmm. It's a bit of a problem. Is there a way for me to view the hex dump? There is a way. That's the wrong thing. This thing does that? Yeah. All right. Maybe I can read. So this is O2. So this is env memory. This is mem type. This is 3. So that should be right. Like if we look at the non-shared version, this should have a 2 there. Oh, it's a 1 there. Yeah. Okay. So what's the problem? Well, it's working. It's shared. I don't think there's a way for me to check it though. Surely there's a way. There's always a way. Wasm dis. What's this? Oh, nice. Okay. So it's shared. Okay, it's shared. Shared. So this works. That. Memory binaries to you. Okay. Okay, so when I do the makefile, I just make 2 different types. So instead of calling this, right, I want shared, which means I call this, and then I call shared patch. So shared patch and what else? So shared gets this. Dataset, VM. Okay, so I just do it twice, right? Just do it twice. Maybe instead of doing it like this, right? Maybe instead of doing it like this, I make the shared version depend on this. The shared version depends on this. It literally just copies. Literally just copies this into place and then does it. That's better. Yeah, that's better. So shared gets this. The random wow version gets that. The random that's data set. Yeah, so the data set. Okay, yeah, so these get this then. VM. And this is Random wow gets that. So that's VM. VM. Yeah, okay. And then this is the web miner. So the web miner is just like not a thing. This is getting removed for a moment. It's getting removed. So, okay. So we have RXJS shared. Random wow is another thing as well. So random wow is getting shared treatment. Random wow.js shared. So if we make clean scripts build, hopefully it will work nice. Really? Oh. The webminer stuff. Ah, fine. Okay, so the patching mode. All right, so now we have the binaries that are actually patched properly. So what needs to be changed is very simple. It's just like, what? Okay, what needs to be changed is the actual implementation. The VM single. Oh no, it's a dataset. Dataset TS. What's dataset JS? Nothing. Dataset TS. So this is, yeah, so this is memory. Shared. Okay, so this is, yeah, that's fine to have. Okay, so shared isn't a thing anymore. Shared's not a thing that we check for. How do you deprecate something nicely? I'm going to ask my web dev friends, or maybe if there's a web dev in here. How do you like deprecate? I want to deprecate this. How do you do this nicely in JavaScript? JS stock. Deprecate npm. No, deprecate node. I don't know JavaScript. Fuck. Deprecate. Ah, here it is. Okay. Optional reason. This has no effects. There are. How do I like? I just like do this, right? Use yeah, so that's useless. So is shared. Is shared is like not a thing. Yeah, patching is not. Okay, so I need to change the way we import the WebAssembly. So ES build. With ES build, I want to add a file. Like, I don't want a URL import. Do I even URL import anywhere? Oh, okay, that's separate. This is the thing. Hmm. I mean, this is probably fine. All right. So I'm not patching this at all. Uint 8 array buffer like. This is fine though. What the hell? What does this take in? Anyway. Surely this is a uint 8 array. Why am I TS ignoring? Okay. I don't even know what's going on with this code. This is a uint 8 array, what? I don't know, I'm lazy. Shared? Oh, yeah, okay. How do I know if the memory is shared ahead of time? Oh, I mean, I can tell, like this, right? Yeah, so I run. So this is memory pages. This like I can use it to extract memory pages, but I also want it to extract the if it's shared memory or not. Yeah, okay. So I'll just do that, right? Oh, this is WASM object dump. I mean, surely like that works. Apparently it doesn't. So I'm just gonna have to just like walk through the binary. This is an import section. Yeah, that works fine. Turns a ball. Turns a ball. Binary p equals that. That's fine. Right. Oh, why does it say shared patch anyway? False, which is what we want. What? Didn't I write that? Oh, it doesn't have anything. Huh. Okay, it was patched. And true. Okay, great. That's good. It worked. Const is... It's just this, right? Yep. And then... No. Okay, better. Ah. Okay. And then VM single. Oh, it started. So is shared has no effect. It's just an assertion. So there's WASM pages, and then there's also How do I assign... How do I assign an alias to this? Oh, it's as. That's like a thing, right? Right. Throw an error, please. Okay, well, obviously, is shared. Right. The shared option has I guess that's fine. Well, it's obviously deprecated. I deprecated it. Actually, it's better to just put it here. Data set is shared. Is shared is not provided because of course it's not. C. What does C do? Oh, that says is shared memory. Is that what is that used for? What is that used for? Oh, okay. Is shared is data set is shared. What's VM WASM? Oh my god. All right. I think that's it, right? Surely that's it. So in here, this configuration is like normal. That's also normal. That's the same as well. That's the same. Let's readme. RXJS shared. This is the Shemem version. RXJS shared. JS shared. So these will need to be changed to that. It's the Shemem version. Yeah, I mean, hopefully that's like not taken. Perfect. Okay. RandomX. My arms hurt. I was bouldering yesterday. I need a... Oh, I have to write docs. Okay, just give me a moment. I'll just like save that for later. So that's shared. It's the shared version. If you want Shemem, which that's fine. If you want Shemem, and let's look at the make file. Okay, I guess that's it. So all we need to do is change this thing, right? So RandomX threaded does not take is shared. So let's say we ran this, it would fail. What? Oh, come on, why does this not even run? What? That's a thing, right? Okay. Let me run this manually. I mean, it should be patched. Okay, and if I were to just run, like... Oh, I'm not passing the needle in. Like, yeah, I'm not passing in the needle. That's when you pass in. Obviously. Because how the hell is it supposed to find it? Okay. If I run RandomX threaded, it's gonna fail. There you go. Shared option has no effect and is an assertion now. Okay, so I need to import properly. It's like here, right? No, I'm looking like here. Okay, so I need to import package RandomX.js shamem shared. Okay, well obviously it doesn't exist, so I need to implement random x add random wow add wow blood what. Why is make not copying these things in? Oh, because they're not part of the build step. Of course. So here's the data sets. Here's the data sets. Shared. You need the VM shared. Random wow shared. Great. Great. Oh, come on. Mismatch in shared state of memory. What? What the fuck? What? What? That's not like real. Let's check if it's shared for real. Shared true. Okay, well, what the hell's the problem? Imported 0. Just log the handle. WebAssembly memory. Dunk, and then the module. Again, jet size. I really should have documented this code. Like, I don't know what the hell is going on. Yeah, oh, this returns the pointer to the jet buffer. Running C is jet begin. That's the key, but you set the key. Okay. Fair enough. Then you run K. K is a jet size, is a jet buffer. Oh, okay, so it does jet the programs. Okay, this literally just contains the superscalar hashes. Okay, that's fine. I don't know what the hell, like, is going on here. Alright, mismatch in shared state of memory. It takes in the cache of the cache handle. Yeah, the thunk is the yeah, that's right. Shared as well. Why is it saying mismatch in shared state of memory? I don't know, man. Link error. I'm just not reading this out. What? Do I not do this? I literally do this. What? I literally do this. You're kidding me. RandomX threaded uses the shared, uses shared. So dataset and the VM must have been set properly. This should like throw an error, right? Yeah, thread's not allowed. Yeah, thread's not allowed. What the fuck? Let me print the path though. Why can't I console log? Yeah, but what? Why is that not? Why is it not doing it? What is path? Oh, okay, so it is getting from the right path. Like, what? The WASM module itself. I don't know what that, like, what they're talking about there. Um... Random, it's the dataset, TS. It's shared. New. Okay, there's nothing else to pass, so it must be inside the WebAssembly. But how? I thought I like literally do this. Like what can I do? Check. Okay. Building. Okay, when it runs, it should. Sanity. Okay, true. Declared 1, imported 0. Oh, what? So this is right. It must be part of the thunk. Thunk. It must be part of the thunk. Surely. No. Okay, that's the problem. The jet buffer is not actually returning the right thing, which that's a problem because it should, because I pass dataset is shared. So what's going on? Asset.c is shared memory. I mean, I should be passing that, but only one way to find out. What? This is passed as true, but it's not importing it. What the fuck? What the fuck? God, that's so weird. is shared memory. I pass. Is shared memory is true. I pass it in. I pass it in here. I'm doing it wrong. It's like EM. It should be EM. I think. Yeah, I don't know why. Why is this like? Oh, maybe because it can't find it. Okay, it is passed as. It is passed as true. This is like crazy. I don't. So the shared memory is imported correctly. Okay. What could be the last one? What's VMWASM? This. The VM should be working fine. It must be here though. No. That's the one, right? Yeah, that's the one. What instance? Is there a way to just like compile this with debug? I can pass instrument. Yeah. What does instrument actually mean? That's like prints. Okay. Okay. Cache VM. Oh, it's VM. Cache VM. Where's the cache come from? Okay. Data sets is where the cache is created. you get a cache here, right? Pass the cache handle, then the VM is created. But the handle is right. So like I don't know. This might be a problem, right? No, this is for threading. So it uses the structured clone algorithm. I'm trying to send the cache to the thing, to the thread, right? Web API types. Can it send a module? Okay, I guess the only way to know is to check it like this. This is the only way to know. So I'm lazy, so I'm just gonna like copy all of this. I mean, how bad could it be? I only need this for 2 seconds. Okay, this is painful, but that's okay, just bear with me. Great, all right. On the cache handle dot VM, so the cache handle, so it's still cache.vm. Okay, hopefully I'm not going crazy. Okay, instrument's not found, but that's fine. Import not found. Oh. Wait, what? Oh. Well, of course it's not found. Oh, what the fuck? Of course it's not found because it's a WebAssembly module, not the bytes. Oh, what the fuck? I don't know what's going on. Maybe I take a look at this, like, closer. So it's definitely, I'm passing the cache handle. Wait a minute. Oh, I'm so stupid. God, I'm such a fucking moron. I'm so stupid. Duh. Oh, come on. What? I just added this. What? Surely this is the fix. There is no other fixes. I won't make that mistake again. But surely this is the fix. What the hell? Well, I mean, no, wait. Why does this need to be? Why isn't page? Yeah, this is the VM. This is the VM. No, this doesn't need to be shared at all. Okay, so I'm stupid. This doesn't need to be shared at all. No, it doesn't. Because this is VM. The VM has private memory. I mean, I think like it's cached on memory. Yeah, I mean, this instance, this memory, is part of the dataset. That must be shared. It's shared. Oh. 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 I know the problem. Surely this is the problem. Right? Where's the VM? How do I make the VM? Oh my god. Please, God. What the fuck is going on? So that's the minor. Oh, this is the VM. The VM doesn't need a shared memory. What was it previously? Why would the VM need shared memory? Doesn't. I don't know. Maybe this is like a thing. Okay, well, obviously not. Oh, I mean, that makes sense, right? This is WASM pages for the dataset. This is the dataset memory. Yeah, this is dataset. Where's the VM come from? Okay, it's just a handle. Take a look at that. I'll take a look at that error message again. Because like I don't know. This is like making me crash out. Can't find module? Oh no. Oh no. Maybe this whole time I've been editing code and it's been using the old thing. Wait, okay. This better not be the case. God, it might be the case. Oh my god, it might be the case. That's fucked up. Why, when I just built it, it didn't build these things? Okay, so I don't know, why is that not? That's not being built. Why is this not being built? The web miner shit like just needs to go. Okay, it builds. The default one does work, right? Oh, it's patching wrong. It's patching wrong. It's patching wrong. But how? Okay, so this is like a corruption. Memory corruption. Why? Remaining byte 6. Oh, no, it's not. It's not. It's not because I'm not like surely this is because of instrument. What? Why? Why is that happening? code extends past the end of the module. Oh. Well, I mean, obviously, like, that's because, I mean, but why is that not, why is instrument not being passed properly? Why is it not being passed properly? Okay, instrument 1. D instrument. This is like the fix, right? Surely. This is the fix. But why? Why when I touch one thing, everything breaks? So that's not the fix. What? So it's something else. I've made changes. What are those changes? Nothing. Well, I mean, is shared like that? That's like a part of something, right? Is shared is useless to have, yeah. Okay. Made changes, what changes? Formatting? Removing is shared. No need to patch it in place because we have dataset is shared. Okay. That's something new. That's something new. That's new. These are like harmless. 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 Expired. Okay, why? What? What? Okay. So that code error is gone now. I mean, good. I mean that's gone. We're still back here, so I'm not going crazy. I'm going not crazy. Running it with instrument breaks everything. I don't know why. Okay. Yeah, it breaks it because it says remaining bytes. Shit. Um. These are like breakpoints. How do I print a warning? Okay. That's running fine. What depends on the instrumentation? Instrument. No. I like. I don't know why. I'm literally not leaving until I fix this. I'm not leaving. Maybe it needs more. I don't believe that, but maybe it needs more. Okay, yeah, instruments being parsed. Okay, so maybe it's something wrong with the JIT, but there shouldn't be. Maybe like an overflow or something? VM. Okay. That's like what? Around 50 kilobytes? But it's like 50 kilobytes, but why why like oh. Huh. Okay. I see the problem. Why is the JIT buffer so small? This is in the data set. Well, okay, no, because this is separate. This is separate. This is in VM single. The virtual machine's JIT buffer is big enough. Right, that's 50. Yeah, this is fine. That's big enough for the superscalar hash. That's not even being touched. This is being touched. Well, no, this is the minor. I don't care about the minor. I swear to God, this is not the problem. But imagine it is. It's not the problem. I mean, that might be the issue. A bit of white space. Okay, I'm going to validate these new modules. That's fine. That's fine. Okay, well, I can just like set that, like enable. That's fine. That's fine too. Does the VM need shared memory? No. No, it doesn't. Oh, that's the problem. Oh, you're fucking shitting me. Holy shit, why? Why am I so stupid? That's the problem. Oh my god, that's the problem. Why does the VM need shared memory? No way. That's a problem, but we also got another problem. Yeah, that's fine. Like, whatever. We'll deal with that. But this fixes it, surely. If it doesn't, I'm like gonna freak out. Oh, thank God. Well, no, wait. This is what I should run. Oh my God. 67 hash rate. Hash rate's running. Okay, it actually works. Where's VTOP? Oh God. Okay. It's like really like just destroying my CPU right now. All right. So I guess instrument is broken. Instrument is broken. I mean, we can commit this and then fix this after. These are the Shemem version. Change the README. Allocating the cache. For using RandomX.js shared to get shared memory. All right. So okay. Not adding an instruction for const 0. Yeah, they didn't add that. Okay. So okay. I'll just commit this. So I mean how do the commit messages usually look? This is the data sets. So this is the data set. Set plus build, and we're also streaming right now. let us hit build. And then what's that? What should I call that? This thing. Deprecate. Then okay. All right, well then that's solved. I mean that is the solve. I mean I did solve something. Something happened. Okay. Yeah, I don't know. This took me so fucking long. Maybe I do this as well. Maybe I do this as well. This will like be changing the JIT. This would be like a non-trivial like kind of thing. I could give this a go. I'm gonna go to the bathroom and then fix this. Like implement this. Fix the issue with equals 1. So these are the most important ones. It's just like a bit more. Okay, there's a bit more. And then, all right, I'm in the bathroom. There we go. All right. Yeah, give me a sec. Okay, I'm back. Time to get to work on this thing, superscalar hash. So I know I exposed it as an API. That was a bad idea. How it works is simple. So RandomX superscalar hash. This is 1, 2, 3, 4, 5, 6, 7, 8 big ints. So it's just 8 times 8 bytes. This is 64 bytes. So the superscalar hash is basically it's generated code by the dataset used to fill the dataset. So the dataset creates these superscalar hashes. It creates them at like runtime, right? It jits them. I think I can show. I think I can show it off. Okay. So here, right? This is the dataset. All of the virtual machine does is read its items, right? How does it generate those items? So first it initializes the cache. It uses argon2. This takes a while. And then takes from the key as well, generates these superscalar hashes. These superscalar hashes are basically functions. It's just all integer instructions. So where's superscalar hash? Here's an example of a superscalar hash, right? It takes in values R0, R1, R2, R3, R4, R5, R6, R7, right? Takes in these values. Makes this result, this thing, where it's just like these things. What it does, and then it goes all the way down. It's just like all of this. It's just like the entire thing is just this. And then it like at the very end, it just returns them. Right? It's just like get. Oh, where is it? Here, right? It's just like get. Returns 8 integers, 64 bytes. Right? So this is the signature. And we should probably not make this public because it will be better to change this signature to return instead of returning 8 integers, I return 4 vectors. So that that might be better. It might be better. I don't know if I'm gonna return 4 vectors. I'm just gonna deprecate this, like not make this public. Like where is this even used? Where is this even used? So this is to go. The VM, the dataset exports this. So this is gone now. The VM. Oh, how do I make this like private? How do I make this private? Oh, it's export all from this. Export all from this exported. Huh. I'm gonna be lazy and do this instead. This is going to be deleted anyway, but this is going to stay. I'm going to deprecate these things. The superscalar hash stuff. If I were to change this to return vectors, I don't know how much of a performance increase this would be. It would be like minuscule. It would be nothing. But I don't know. It would be minuscule. It would do nothing. But the deprecation is needed, unfortunately. Unfortunately, that's just not something I'm going to do. Okay. I guess we can just like try and fix this. Until then, though, it would be nice to figure out why FMA is broken. It would be nice to like test this out. Be nice to test this out. Like, well, where's like the WebAssembly.org, right? WebAssembly. Custom text format annotation. Relax SIMD. Okay, it doesn't even support Relax SIMD. Like, what is Firefox even doing? Firefox has nothing. What a shit browser. Oh my god. Support things. Okay, so it supports... Whoa. Whoa, 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 whoa. What are these? These are new? Holy shit. Wide arithmetic? I need that. What's the shared everything threads? Oh, okay, well that's... I don't know why you'd want that. Well, the component model just needs to die. What's profiles? Fuck do you mean madd? You're kidding. They get madd? They get madd, and then for F32, F64, we have to live with the relaxed variant. Okay. You're trolling. You're like actually like fucking with me right now. Yeah, okay. I mean, it works there. So let's just like give it a go. It probably works on Node.js, right? Yep, 21, 25. Okay. Well, I mean, if it works there, let's enable it again. Let's enable it again. So, in the JIT. Here, right? JIT FMA. Hash mismatch. Why? 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 Why is it hash miss? Why? Doesn't it not support FMA? No, no FMA. Why is it bang FMA? Well, I guess like because it doesn't work. Maybe there needs to be a better FMA detection. MAD goes the other way around, right? I actually can't tell. I think it does. I think this is just like something you can't. Node.js look at JIT executable code. Maybe there's a way for me to like look at the JIT. No. See. Okay. That probably won't work. No, it doesn't. Doesn't. This probably doesn't work at all. Oh, it does work. What? It works. Okay. Shit, alright. I just want this to run once. Oh, God, it's gonna run 8 times for all 8 of the things. Okay. Let's take a look. Great. It'd be nice to know what these functions are named. But we didn't fix the instrument problem. Maybe we do it like this, right? Instead of instrumenting the code, we just do this, right? Instrument 2. Okay, well, I mean, it's running just fine. Let's do it like this. So these functions should have names, right? Yes, these have names. Great. Okay, RandomX VM. Okay. So. Wow, you can actually. I actually have not ever looked at the code. Okay, so RandomX VM. All right. Uses liftoff. What are the tiers? Node.js VM tiers. This is just liftoff. Like, what is liftoff? Liftoff. What? What is the slop? How? Let me just go to the website. Because I know this is on the website. No, it's V8. V8.dev. Yeah, okay. Okay. Yeah, we only get the baseline jet, unfortunately. So we can actually Control F for these, because I give them names. They actually get annotated. So for example, here, name section, right? I can give these names. So f add 0 gets a name. Great, I can find it. It's a jump table. Okay, f add 0 is doing way too much. What do these do? Okay. Adds 1 and 2, puts it in 0. You sure? How does the calling convention work? Okay, well, it just adds them. Like, it just adds them. Okay. That's fine. Fmul 0 as well. It multiplies them. Okay, easy. Fmul FMA. Fmul FMA. Oh, why is it not? Why was it not passed? Why is that code not generated? Oh, they're not given names. FMA is not given names. Okay, so the fmul that I'm talking about is the fmul. Okay. Vmul PD. Okay, and I should see the emed down below. Maybe it's being optimized. No, but it's liftoff. It can't be optimized. Okay, well, that's just a jump up here. Let's move APD. Move align pack to double precision. Okay. So it does the multiply. Why is it branching? Maybe here it performs the emad? No, it doesn't. What? It doesn't. Oh, well, okay. What is this? What's it calling? What is this? What is this thing? It's all the exact same code every time, right? Yeah, basically. It's the exact same code every time. But there's only one mul, which is weird. Maybe in the baseline jits there's no guarantee that MAD could be generated. Oh no, here it is. What? I can't read. Okay, I'm looking in the wrong place. Okay, FM add for mad. FMA add, okay. What? It's doing it. It's doing it. I don't know why it's not. I don't know why they're mismatching. Right? So it is they are doing it. But what's happening? Like, it's being called everywhere. I don't know why. I don't know what the difference is. Because for example, right, these two functions are like exact. Like they give the same output always. Always. Now there's something I haven't tested. I have tested it when it compiles to x86. And I use a polyfill, like a SIMD, like a WASM SIMD, like polyfill. But I haven't actually run it. Well, it wouldn't hurt to like test it out. Maybe maybe here, right? I can just copy this entire thing. I forgot how to do modules. So hopefully like I remember. Hopefully I remember how to do this. Oh wait, no, I can just do WASM dis. WASM dis. WASM dis. Okay, when it goes to make, it deletes the semifloat. what? Okay, it's git stub sources. Yeah. Yeah, here. Okay. Okay. Here's this. Okay, and I just like great. All we really need is fmol1 and fmol1, fmol fma1. And then maybe like, I don't know, maybe we might want like this. We want like square root as well. So this is function 9. So just delete up till 9. And 12. Delete up till 12. Okay, I'll just take these two. 9 and 12. And then the rest is deleted up to 12. Okay, 9 and 12 are the two things that we want. We don't need memory. Wasm ass. Okay. Okay, that works. All right. And if we are to test this, right? We're going to test this like this. So this wasm file. Okay, so to get the bytes, I forgot how to do this. os.read. Okay, whatever. How do you read a file in Java? Read a file in Node.js? Great. Thanks. No, it's not UDF8, it's binary. No, is there a way to read a file without it being returned to me as a string? You're fucking shitting me. Oh. Okay. That's stupid. So, okay, equals new assembly.module. Dollar. Oh, I mean, I guess like it's like instantiates the same thing. M dot instance module exports. I forgot how this works. So the instance is something separate. Oh no, this takes in it's annoying. These take in vectors. I can't put in numbers into them. Oh my god. Okay. I'll just do this. 99. F64. F64, result F64. How I think I've forgotten like how these work. So it's like why is that using one space? Are they using one? Are they using one space for a tab? Jesus. Okay. Sure. Feel like splat. Local.get 0. And then call. And then extract. Hopefully this works. Oh, this is type 0. Okay. Type 2. Great. Alright, that wasn't that bad first try. Alright, and I can pull this. That's very small. Why is that? Why is that like that? Oh, because zeros don't exist. There's like 1 and 2, right? Take 1 and 2. They multiply to be 2. So okay. The 0 is just not a number that's handled. Which I mean that's fine. FMA 1. Oh my god. So that's why? Why is that like... That's really weird. Oh, what is it? It's not print code, it's like... It's print code. Whoa, that's a lot of code. Why is that? That's not necessary. Why do you need all of this? This is function 1. This is function 2. This is like function 3. This is function 4. Index 4. vmol pd fmadd. So FMA is actually running. Maybe maybe this is straight up like FMA is bugged. FMA seems like straight up bugged. I'll like commit these. Oh, it finished apparently. Whoops. So FMA instructions like do exist in the binary, which you know, seems interesting. FMAT? No, FMA. Yeah, I mean, this is a problem. Investigates. RandomX. So in the issues, I should probably clean out these issues as well. Hmm. Lift off. You can see the actual instructions of the tests in the tests using the poly Actually, I think I can compare assembly output. I'll just do that right now. Obj dump m intel semi float disassemble mul1. Oh, pretty. Okay. Fmul FMA. Okay. VFM sub. I shouldn't cause any. That shouldn't. That shouldn't do that. That shouldn't cause any problems. FM sub C, which is this parameter. Comparing the assembly output is like, as well as a problem. So the question is, addition, is there a reason for that? NMAD. But is there a reason for that? I don't think so. Yeah. Yeah, that's a problem. So FMA can't be used at all. Oh well. I think that's it though. I think that's it. This is like a low status issue. The binary patching was like me fucking around doing nothing. This was FMA. Alright. Holy crap, that's a long stream. 1250 E. What's that for? Basically 4 hours. So that's chill, it's not that bad. Okay. 3.8. Get site. Alright, so what to do next time? I guess I can look into this on my own. Batching API and a miner. Okay. Batching API and the miner. What is stremma? What? Why is this in my history? Okay. Yeah, tick. All right. Okay. I think that's it. This was a long and uneventful stream, unfortunately. All right. It's not very glamorous. Okay. Bye, everyone.